See the next question from 9th standard motion chapter, Ncert exercise problem number 9. Okay, see the question from the basic concept. Listen, state which of the following statement are possible and given an example of each of this. Okay, ரெண்டு statement கொடுத்திருக்காங்க. இந்த statement possible இல்லையா? Possible na we want to give some example. That is the question. See the first question, an object with a constant acceleration but with zero velocity. Acceleration is constant. Okay, acceleration is constant but velocity is zero. This is question. This is possible இல்லையான்னு கேட்டிருக்காங்க. Okay, right. So I mean acceleration is constant. Okay, constant acceleration. Okay, acceleration will be constant but the velocity should be zero, but they didn't mention initial velocity or final velocity something. Okay, say for example, let us take our earth. So you know earth acceleration due to gravity value is 9.8 approximately, is constant, is everywhere. Okay, but depends upon the height it will be vary, and depends upon the depth it will vary. You will be studying higher study. Okay, generally the gravity value, how much, that is 9.8 meter per second square. But if I throw this object, for example, let's take this one, this bob. Okay, I take this bob. Okay, now listen, now in my hand now the gravity value is 9.8, because if I leave this it is moving down. Okay, suppose from this place if I leave it will moving down, because here also same 9.8, here also same 9.8. There is acceleration due to gravity towards the earth. Okay, so because that acceleration should be constant, acceleration is constant, but I can throw this. If I throw means what will happen? I give initial velocity, then it will moving upward direction. After reaching the particular height, that means the maximum height, its velocity is 0, but acceleration is there. Correct or not? Yes, in my hand now 0 velocity, but even the acceleration is there. Okay, but if I throw upward direction, if I throw the upward direction, okay, if I throw the upward direction, the velocity reduce, finally 0. Final velocity 0, but acceleration is still there. Okay, so we can say that constant, acceleration is constant, but the velocity is 0. See that when a ball is thrown up at maximum height, okay, it has the velocity, it has the zero velocity, although it will have the constant acceleration due to the gravity. So that value, you know, which is equal to 9.8 meter per second square. That's all. Okay, quite easy. See the second question. An object moving in a certain direction, a particular direction dependent on object move with the acceleration in the perpendicular to the direction. Okay, an object moving in a certain direction. Okay, but the acceleration is perpendicular to the direction. Is possible or not? That is a question. Yes, it is possible. Say for example, let us take one thread, then bob. Okay, it will be suspended from this position. Okay, you know very well this is point of suspension. This is the bob. Now it is moving in this motion. Now let us imagine, suppose if it is traveling in a circular path. Okay, so now this is acting as a radius. So you know very well. Okay, now it is in the circular path. Suppose if I leave this object, what will happen? Suppose if I leave this object. Okay, suppose now it is rotating in this direction. So now in this position, if I leave it means it will travel in a straight way. Okay, suppose, see that if I leave this object from here while reaching the maximum height, I mean this height, if I leave it means what happens? This travel in this direction. So in which it is traveling the path of the circular path, Okay, so in which position I have to leave this object? It is continuously travel in a straight way. So what I'm going to tell here, for example, see that with the diagram I will explain for the second one. Okay, so you know that this is the circular path. It's a circular path. Now this is center of the circular path. This is the object. Okay, so you must know one thing. Listen. Now this object moving in a circular path. Okay, so that means here this force always towards to its center. Okay, it is always towards its center. Okay, this force is always towards its center. For that only it is maintaining a circular path. Okay, so please listen. So for example, the force always towards its center path. Okay, so it's a force direction. So here we can say the force direction only the acceleration direction. So this is the acceleration direction. Okay, but suppose if I leave this object, I leave this object. So what happened? It will go like this. So if you observe that these two perpendicular, this is the direction of motion. This is one particular direction I leave it. So what happened? What happened? It is perpendicular. So it is a movement direction. It is a displacement object. It is a motion direction. So it should be the perpendicular. It is a 90 degree. So acceleration is perpendicular to its the moving direction. Suppose when the object is here, when the object is here, if I leave it, what happens? It will move this way. Suppose when the object is here, if I leave it, what happens? It is moving this direction. Suppose when the object is here, when the object is here, if I leave it, what happens? It is moving this direction. Suppose when the object is here, this move direction. So it is always perpendicular. Okay, understood? Okay, so that only I mentioned here. When an object in a moving circular motion track, its acceleration is perpendicular to its direction. Okay, that's all. Very simple. Okay.